Champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great tool for you for practicing your entrance exam question papers as well as class 12 mathematics, physics, chemistry question paper. In this video, we will be solving the CBSE class 12 mathematics term 1 paper. So I hope you have already done that, and this particular video will help you better prepare even better for your exams. Students, you must download our app. The link is available in the description box. Let's start with today's paper, Class 12, Term 1, 2022 Mathematics. This video will have about 50 questions, and we are going to start with the question number 1. So in this particular section, you have to attempt any 16 questions out of 1 to 20. They are carrying 1 marks each. All right, let's go. So differential of log x raised to power 5 with respect to x. See, this is a pretty easy question. Don't get confused with this log thing. If I say you have to find out the derivative with respect to x for log of log x raised to power 5. Correct? So this will be given by, first derivative will be given by 1 upon log of log x raised to power 5 into the derivative of log x raised to power 5. Correct? Next, this will remain as such. This will be equal to 1 upon log of log x raised to power 5 multiplied by its log will give me 1 upon log x raised to power 5 into the derivative of, you'll be left with log x raised to power 5. So this is gonna give you 1 upon log x raised to power 5 into log of x raised to power 5 into 1 by x raised to power 5 into the derivative of x raised to power 5. Correct? So this will be equal to 1 upon x raised to power 5 into log of x raised to power 5 into log of x raised to power 5 multiplied by, what is the derivative of this? This is equal to 5x raised to power 4. Correct? So this will cancel, and with this, like, only 1x will remain in the denominator. So the whole term now will become 5 upon x into 1 upon log x raised to power 5 into 1 upon log of x raised to power 5. Right? This is the correct answer. Now let's choose which of the options is correct. Option A. This is the correct answer. Hope you have got that. Next is question number 2. Find the number of all possible matrices of the order 2 by 3 with each entry 1 or 2 is given by. Fine, you're given over here that the order is 2 by 3. So how many number of elements will be there in this matrix? It will be equal to 6. Each place can have either 1 or 2. So each place can be filled in 2 ways, right? There are 2 digits. So each place can be filled in 2 ways. Therefore, the number of possible matrices will be, therefore, number of possible matrices will be given by 2 raised to power 6, which is equal to 64, and option C is the correct answer. Hope you got that. Next is question number 3. A function f from real to real numbers is defined as fx is equal to x raised to power 3 plus 1. Then the function has no minimum value, no maximum value, both minimum and maximum, neither maximum nor minimum value. Okay. So here you are given that fx is equal to x cube plus 1 or Let's find out the derivative. This is 3x square, and the second derivative for the same will be equal to 6x, right? F dash x is equal to 0 for either the minimum or the maximum value. We'll put that equal to 0. That means 3x square is equal to 0, which simply means x is equal to 0. Now, at x is equal to 0, what is the value of second derivative? Which was equal to 6x. This is also equal to 0. Thus, fx has neither the maximum nor the minimum value because that depends on the second derivative. So, fx has neither maximum nor minimum value. That means you have option D as your answer. Hope you understood. Next is question number 4, trigonometric problem. Sin y is equal to x into cos a plus y, then dx by dy is what? Find your given sin y is x cos a plus y, or x is equal to sin y upon cos a plus y. Now differentiating with respect to y, we get dx by dy is equal to cos. See, first of all, you will have the denominator square, cos square a plus y. So cos a plus y into the derivative of the numerator, which is equal to cos y, minus numerator into the derivative of the denominator, which is minus sin a plus y into the derivative of a plus y, which gives you 1. So I will write it just as such. Now this will be equal to cos a plus y cos y plus sin y sin a plus y whole divided by cos square a plus y. This is equal to dx upon dy. Okay. So dx upon dy, this is cos a cos b plus sin a sin b. Know that formula is for cos a minus b. This is equal to cos a cos b plus sin a sin b. So this is equal to cos a minus b whole divided by cos square a plus y. You will have this as cos a cos square a plus y. So that's it. This is what we needed. So this is the answer. Let's check with the options. Cos a upon cos square a plus y is option A. Hope you got that. Let's move to the next question, number 5. The points on the curve x square upon 9 plus y square upon 25 is equal to 1 with the tangent is parallel to x-axis are. So you are given the equation of the curve as x square upon 3 square, y square upon 5 square is equal to 1. The points on this curve where the tangent is parallel to the x-axis. For that, let's differentiate this with respect to x. Differentiating both sides with respect to x. What you get is, here will be 2x upon 9 plus 2y upon 25 into dy by dx is equal to 0, right? Or dy by dx will be equal to minus 2x upon 9. Fine, let's write it here only. 2 upon 25. I'll keep it as such right now. Okay, first thing is this 2 and 2 will cancel. And you have now dy by dx is equal to minus 25x upon 9y. Yeah, here was y as well. Forgot to write. Okay, so this is the value for dy by dx. Now, since the tangent is parallel to the x-axis, therefore the slope of the tangent is 0. Since tangent is parallel to x-axis, therefore slope of tangent is 0. Okay, that means dy by dx is equal to 0. What was dy by dx? It was minus 25x upon 9y. This is equal to 0, which is possible only if x is equal to 0. Because y cannot be equal to 0, it is in the denominator. Okay. Now, if x is equal to 0, I put that in this equation 1. What you will get is 0 plus y square upon 25 is equal to 1, or y square is equal to 25, y will be equal to plus minus 5. So the required points will be 0 to 5 and 0 to minus 5. Let's check with the options. You have this option B as the correct answer. Hope you got that. Let's move to the next question, number 6. 3 points P, Q, R are collinear, then X is equal to what? Okay, so I'll use the matrix form to solve this question. You know, in the matrices, if the 3 points, generally, if I talk about generally also, the 3 points are collinear, then the area of the triangle formed by those 3 points will be equal to 0. If 3 points are collinear, then area formed by these points will be 0. Okay, because they are lying in the same point. This P, Q, R. Maybe the positioning is different, but they are lying in the same line. Okay, so finding out the area, I'll use the matrix form that is given by half of x1 minus x2 and x2 minus x3, y1 minus y2 and y2 minus y3. This is equal to 0. So let's fill in the coordinates now. This is 1 by 2, 2x minus 0. Yeah, 2x minus 0. And the next one will be equal to 0 minus of x plus 3. Here you will have the next one as x plus 3 minus x, and here you will have x minus x plus 6. Now this is equal to 0. Okay, if these points are collinear. Now let's find out a determinant. You have here 2x into x will cancel. These two x will cancel into 6 minus this x, and x will also get cancel 3 into minus x minus 3. This should be equal to 0. Okay, fine. So you have 1 by 2 into here will be 12x plus 3x plus 9 is equal to 0. Okay, so you can say here is 15x. Wait, here was minus 6. This one was minus 6. Okay, so this has got to be minus 12. This gives me minus 9x plus 9 is equal to 0, which gives you x is equal to 1. So this is the value for x of x which you needed to find in the question. 1, option D is the correct answer. Hope you got that. Let's move to the next question. Question number 7. The principal value of cos inverse 1 by 2 plus sine inverse 1 minus 1 by root 2 is given by. Fine, this is very easy. Cos inverse 1 by 2 plus sine inverse minus 1 by root 2. This can be written as cos inverse 1 by 2 minus sine inverse 1 by root 2. So let's make the table once. I hope you already know the table, but still, let's make it once. So here is for 0 degree, 30, 45, 60 and 90 degree. This is 0. This is 1 by 2, 1 by root 2, root 3 by 2, 1. This is 1, root 3 by 2, 1 by root 2, 1 by 2, and 0. Okay, so what is the value for cos inverse 1 by 2? That is equal to 60 degree, and 60 degree means pi by 3. Okay, minus sine inverse 1 by root 2. That is for 45 degree. That means this is equal to pi by 4. Correct? Pi by 3 minus pi by 4, this is equal to 4 pi minus 3 pi upon 12, which is pi 12. This is the answer to the question. Hope you got that. And we have option A as the answer. Hope you understood this. Next is question number 8. It says if x squared plus y squared whole square is equal to xy, then what is the derivative of y with respect to x? Okay, let's write this first. X square plus y square into y square is equal to xy. This can be written as x raised to power 4 plus y raised to power 4 plus 2x square y square minus xy is equal to 0. Now let's differentiate it. Differentiating with respect to x. This will be 4x cube plus this will be 4y cube into dy by dx plus 2. Okay, this will be 2 first function into derivative of second plus second function into derivative of first. Okay, and minus xy, this will be minus of first function into derivative of second plus second function into derivative of first. This is equal to 0. I hope you got that, right? So next, this will be, let's open up the brackets. This will be 4x cube plus 2. Okay, wait, this is 2x square. Actually, this is 4. Wait. Okay, so this is 4x cube plus 4x y square, right, plus minus y. Minus y, then you have 4y cube into dy by dx plus 2 not 4x square y into dy by dx minus x into dy by dx is equal to 0. All right. So let's make it. This becomes 4x cube, 4xy square minus y. I'm taking dy by dx common now. So this will be plus 4y cube plus 4x square y minus x dy by dx is equal to 0. So solving this, this is the other terms. So dy by dx will be written as minus of 4x cube plus 4xy square minus y whole divided by 4y cube plus 4x square y minus x. Right? I hope you are clear till here. That's it. Now, just one more thing, because you don't have anything minus. See, there is no minus over here. So I'll solve it further. This can be written as dy by dx is equal to y minus 4x cube minus 4xy square whole divided by 4y cube plus 4x square y minus x. So this also can be written as y. I'll take 4x common, x square plus y square whole divided by 4y into x square plus y square minus x. This is the value for dy minus dy by dx. Okay, so this is the answer to the question. Let's check. You have option B as your C as your answer. Hope you got that. Let's move to the next question, number 9. If a matrix A is both symmetric and skew symmetric, then A is necessarily a diagonal, zero, square, or identity matrix. Okay, you are given here that A is symmetric matrix, right? Which simply means A transpose is equal to A. And if A is skew symmetric, what does that mean? It means A transpose is equal to minus A, right? Also, the diagonal elements are 0. Diagonal elements are 0. Now, it is given that A is both symmetric as well as asymmetric. A is symmetric as well as skew symmetric. Right? It is both of these. That means A is equal to A transpose is equal to minus of A, which is only possible if A, see, if A is equal to minus of A, that means 2A is equal to 0, which is the only condition when A is a 0 matrix, right? Let's see. If I make the A as a 0 matrix, which is 0, 0, 0, 0, what will be the A transpose? This will be 0, 0, 0, 0. And what will be minus of A? This will be again 0, 0, 0, 0. So that means if A is both symmetric and skew symmetric matrix, then A is necessarily a 0 matrix. That makes option B to be the answer. Hope you understood that. Next is question number 10. Okay, it says let X be the set defined by 1, 2, 3, and relation R is defined as in X as R is such that 1, 3, 2, 2, 3, 2, then the minimum ordered pairs which should be added in the relation R to make it reflexive and symmetric both is fine. See, you want to make R reflexive. R will be reflexive if it contains elements like 1, 1, 2, 2, and 3, 3. Right? Now, since this 2, 2, it belongs to this R. So, we need to add 1, 1 and 1, 3 to this. Correct? So, it is asking you what minimum ordered pairs should be added. So, first, if it has to be the reflexive, you need to add 1, 1 and 3, 3. Okay? So, these two pairs need to be added. Second, it says it should be symmetric. When it will be symmetric? For R to be symmetric, it will be symmetric when it will contain 2, 2, 1, 3, 3, 1, 3, 2, and 2, 3. Correct? Then only it will be symmetric matrix. Right? Now, you already have the 2, 2. And yeah, that means you need to, yeah, wait. You already have 2, 2 and 1, 3 and 3, 2. So these three you already have. So what do you need to add is 3, 1 and 2, 3. So minimum ordered pairs which need to be added are 1, 1, 3, 3, 3, 1, not 3, yes, 3, 1 and 2, 3. So these are the ordered pairs which need to be added. Let's check. You have this in the option C. Hope you got that. Next is question number 11. A linear programming problem is defined as minimize. You have to minimize z is equal to 2x plus y. Subject to these constraints. X is greater than 0, less than equal to 9, y is greater than 0, this and this. The feasible region has 5 coordinate points, including this, or this, or this, or these two. Okay, so let's plot the constraints. This from here, you can say x is equal to 3, x is equal to 9, x is equal to y. From here, x minus y is equal to 0. This gives you x is equal to y. And from here, you have x plus y is equal to 14. Now, let's make the graph for this. For the graph, from that, let's make the graph. So I'll make the 4 equations. I'll rewrite the 4 equations. You have x is equal to 3, x is equal to 9, y 14. Okay. So here is the coordinate axis. Okay. Here we are. And x is equal to 3. This will be round about somewhere here. This will be x is equal to 9. This is your y-axis. And x is equal to y will be this line. Okay, then you have x plus y is equal to 14. This line will look something like this. This is actually not the proper graph. Wait, I'll redo this one. So this is x is equal to 3, 9, x plus y is equal to 14, and x is equal to y. So this will have the graph. Let's make it here. Okay. So this is the line y x is equal to 3. This is the line x is equal to 9. This is the line x is equal to y. And let's make the line x plus y is equal to 14. So when this is the point 0, 14, and this is the point over here, it will be the point 14, 0. So let's join these 2 points. All right. You will find out this is the line x plus y is equal to 14, and this is the line x is equal to y. So you will find out the point of intersection of these 2 lines. Let's find the point of intersection. Of x is equal to y and x plus y is equal to 14. This gives me 2x is equal to 14 or x is equal to 7. When x is equal to 7, y will also be equal to 7. So this is the first coordinate point, 7, 7. The second one over here. This was the line x is equal to 3. So x coordinate is 3. And see, this is also falling on the line x is equal to y. So if this is 3, the y is also 3. Hope you got that. Let's name these points. This is O. Let's say this is A, B, C, D. Let's say this is D. D, E, and that's it. Okay, fine. So we got this point, and now this point. Here was 9. This is x is equal to 9. This is x is equal to 3. And when x is equal to 9, according to this, y will be equal to 5. 9, 5 is the next point. This is 14, 0. This is 0, 14. And this point is 3, 0. This is 9, 0. So now what the question was, feasible region is. So from the graph, it is clear that the feasible region is this. This one. Okay. The feasible from the graph, it is clear that the feasible region is A, B, C, D, E, A. A, B, C, D, E, A, this region. Okay. So these feasible region has how many corner points? This is the 5. See, 1, 2, 3, 4, and 5. So this has 5 corner points. Everyone is saying 5 corner points, including 0, 0 is not there. So this is not included. 7, 7, 3, 3 is there. 14, 0. 14, 0. No, this is not the one. This is wrong. 3, 6. No, this is not the one. So we got option B as the correct answer. Hope you got that. Next is question number 12. The function fx is equal to e raised to power 3x minus e raised to power minus 5x upon x. If x is not equal to 0 and this is equal to k, if x is equal to 0, this is continuous. At x is equal to 0, you have to find out the value of k. Okay. So you are given that function is continuous. at x is equal to 0. Then what do you have? Left hand limit is equal to right hand limit is equal to f of 0, right? If the function is continuous, or you can say left hand limit is equal to right hand limit is equal to k, because this is given k when x is equal to 0. I can write that. Okay. Now, what about the left hand limit? Left hand limit is limit h approaching 0 e raised to power. It was 3 into x. So 3, 0 minus h minus e minus 5, 0 minus h whole divided by 0 minus h. That makes it limit h approaching 0 e raised to power minus 3h minus e raised to power 5h whole divided by minus h. Hope you got that, right? Okay, so now I'll be doing, I will be adding and subtracting one. Okay, now this will be limit h approaching 0 e raised to power minus 3h minus 1, right, upon minus h. Okay, then this is plus limit h approaching 0 minus of e raised to power 5h, and here will be plus 1 upon minus h. Hope you got this. Okay, so limit h approaching 0, this can be written as e raised to power minus 3h minus 1 upon minus h. I will leave as such. Why? Because there is minus 3h over here. Okay, plus limit h approaching 0. Now here h should be positive, so this can be done this way. E raised to power 5h minus 1 upon h, multiplying the numerator and the denominator by minus 1. Okay, fine. So now this becomes a okay, one thing, but I need to have a 3 and a 5h over here. Let's do one thing. 3 limit h approaching 0 e raised to power minus 3h minus 1 upon minus 3h plus 5 limit h approaching 0 e raised to power 5h minus 1 upon 5h. This is equal to 3 into 1 plus 5 into 1. See, this was equal to k, right? We talked about this. This limit is equal to k. So this is equal to k, k, and this is equal to k. That makes k is equal to 8. So this is the answer to the question. You had to find out the value of k, and that came out to be 8, which makes option D to be the answer. Hope you understood. Next is question number 13. If Cij denotes the cofactor of Pij, where of matrix P, then you have to find out the value of C31 multiply C32. Okay. All right. So first thing, Cij denotes the cofactor of this, right? Pij. You have to find out C31, and the other thing you have to find out C23. So that means third row first column, second row third column. This will be equal to minus 1 raised to power 3 plus 1 into now third row first column I will leave. What will be third row first column I will leave. So I'll be left with minus 1, 2, 2, minus 3. And similarly over here, this will be minus 1 raised to power 2 plus 3. Second row, third column, I will leave and I'll be left with 1 minus 1, 3 and 2. Okay. So this becomes minus 1 raised to power 4 whole multiplied by 3 minus 4, which is equal to minus 1. And this is equal to minus 1 raised to power 5 multiplied 2 plus 3, which is minus 5. Okay. You had to find out the product of these two. So C31 multiply C23 is equal to minus 1 into minus 5, which is equal to 5. And this is the answer. Okay. Option A is the correct answer. Hope you got that. Next is question number 14. The function y is equal to x squared into e raised to power minus x is decreasing in the interval which of these? You are given the function fx is equal to y, which is equal to x square into e raised to power minus x. Let's differentiate both the sides. Dy by dx will be given by 2x into e raised to power minus x first function into, here I'm taking this as a first function. So first function to derivative of second plus second function into derivative of first. Okay, this makes it, I'll take e x into e raised to power minus x common 2 minus x. Okay, now the function is said to be decreasing. If the function is either decreasing or increasing, then the derivative got to be 0. For decreasing, this first derivative got to be 0. If this is equal to 0, this means e x into e raised to power minus x, 2 minus x is also equal to 0, which simply means that either x is equal to, this is equal to 0 or this is equal to 0. Either x is equal to 0 or 2 minus x is equal to 0, which gives you x is equal to 2. So there are 2 points, x is equal to 0 and x is equal to 2. This divide the real line, divide the real line into 3 disjoint intervals, that is minus infinity to 0, 0 to 2, and 2 to infinity. Right? Hope you got that. So you have this option D as the answer. Hope you got that. Next, question number 15. R is a relation defined by xy ordered pair where x and y belong to integers and x squared plus y squared is less than equal to 4. Is a relation in the set Z. Then what is the domain of R? Fine. You are given the relation is xy such that x comma y belongs to integers and x squared plus y squared is less than equal to 4. Okay. Fine. See, y over here will be given by y is equal to 4 minus x square under the root. Now, since it belongs to integers, right? Therefore, x can have only the value for as 0, plus minus 1, plus minus 2. Right, it can't have greater values than that because then the square root, inside the square root you will have a negative term if you will take x value higher than this. When x is equal to 0, what will be the value of y? It will be plus minus 2. When x is equal to 1, the value of y will be plus minus root 3. And when x is equal to 2, the value of y will be equal to 0. Right, I hope you got this thing from this equation. And higher values of x are not possible. That's it. So the required domain over here will be, required domain will be only these values. So 0 plus minus 1 plus minus 2. These are the 3 possible values. This option B is the correct answer. Hope you understood that. Next is question number 16, system of linear equations. This will be consistent. If consistent means, that means they will have a solution. Okay. The system of linear equations is given by 5x plus ky is equal to 5. 3x, 3y is equal to 5. Now for consistent, what is the condition? That a1 upon a2 is not equal to b1 upon b2 is not equal to c1 upon c2. Right? That means they are intersecting lines. Okay. So that means what is a1? 5, a2, 3, b1, k, b2, 3. Sorry, this is k upon 3. So they are not equal. I'll rewrite this. Wait. So 5 upon 3 is not equal to b1 is k and b2 is 3. 5 upon 3 is not equal to k upon 3, or you can say simply 5 is not equal to k. Okay, that makes option D to be the correct answer. Hope you got that. Next is question number 17. Equation of the tangent to this curve y into 1 plus x square is equal to 2 minus x if it crosses the x-axis is given by. Okay, we have the equation of the curve given to us. X into 1 plus x, y into 1 plus x square is given by 2 minus x. Let's say this as number 1. Okay, so let's differentiate both the sides with respect to x. So differentiating both sides with respect to x. You have first function to derivative of second plus second function into derivative of first is equal to minus 1, right? I hope you're clear with this. This makes 2xy plus 1 plus x squared dy by dx is equal to minus 1. Or you can say dy by dx is equal to minus 2xy. Minus 1 whole divided by 1 plus x square. Correct? Let's say this is equation number 2. Now the given curve crosses the x-axis. It's given it is crossing the x-axis. On what happens on the x-axis is you have the y always 0. Okay. So since curve passes through x-axis, that is y is equal to 0. So what will you have over here is 0 into, from I'm using 1, okay, from 1. 0 into 1 plus x square is equal to 2 minus x. That will make x is equal to 2. Now, since the curve passes through the point, what is the point over here? 2, 0. Since the curve passes through the point 2, 0, what is the derivative at that point? Dy by dx at 2, 0. This is equal to, from here, I'm using equation 2 now. Okay, from 2. This is given by minus 1 minus 2 into 0 whole divided by 1 plus x square. So 1 plus 2 square. That makes minus 1 upon 5. Right? Now, dy by dx at this point, this represents nothing but the slope. Okay. So slope of the tangent to the curve is minus 1 by 5. Slope of tangent of the curve passing through 2, 0 is minus 1 by 5. Okay. Slope of the tangent, wait. It makes 2 lines. So slope of the tangent of the curve is equal to minus 1 by 5. Now let's make the equation of tangent at 2, 0 and the slope is minus 1 by 5. So the equation will be given by y minus y1, which is 0, is equal to slope. I'm using y minus y1 is equal to m into x minus x1 formula. Okay, so this is minus 1 by 5 x minus 2. That makes it y is equal to minus 1 by 5 x minus 2, or 5y is equal to minus x plus 2, or x plus 5y is equal to 2. This is the required equation. So it was option C. Hope you got that. Next is question number 18. Matrix problem 3C plus 6. So this is a square matrix is equal to this matrix are equal. You have to find out the value of AB minus CD. So actually this is very easy. 3C plus 6 is equal to 12. Which makes C is equal to 12 minus 6 upon 3, which is equal to 2. Next, A minus D, and fine. I'll go with this. 2 minus 3b is equal to minus 4. So minus 3b is equal to minus 6, or b will be equal to 2. I got the value for C and B. And next I have a minus d is equal to 2. A plus d is equal to minus 8. Which makes, let's add them. You have, these two will cancel. 2a is equal to minus 6, or a is equal to minus 3. If a is equal to minus 3, then a minus d is equal to 2, minus 3 minus d is equal to 2, or d will be equal to minus 5. I got all the four values, right? Now let's write down. You have a C as 2, B as C as 2, B is also 2, A is minus 3, and D is minus 5. You have to find out AB minus CD. A was minus 3 into 2 into 2 minus 5. This is minus 6 plus 10, or 4 is the answer, right? Option A is the correct answer. Hope you got that. Let's move to the next question, number 19. The principal value of tan inverse tan 9 pi by 8 is what? You have to find out the principal value, right? So here is 9 pi by 8. This is tan inverse tangent. 9 pi by 8 can be written as pi plus pi by 8, correct? And you know tan pi plus x is equal to tan x itself. That makes it tangent inverse tangent of pi by 8, which is simply equal to pi by 8, right? See, pi by 8, it belongs to the minus pi by 2 to pi by 2, right? So tangent inverse tangent pi by 8 will give you the value as tangent as pi by 8. That is option A. Hope you understood that. Next is question number 20, matrix problem again for two matrices, P and Q transpose. What is the value of P minus Q? Okay, one thing you are given that you have this Q transpose as minus 1, 2, 1, 1, 2, 3. So what is the value of the transpose of QT transpose? This will be minus 1, 1, 2, 2, 1, 3, right? Now, this is what? This is equal to Q itself, right? Q transpose will give you Q itself. Now, what do you need to find out was P minus Q. What was P matrix? P matrix was 3, 4, minus 1, 2, 0, 1, minus 1, minus 1, 1, 2, 2, 1, 3, which will give you 3 minus of minus 1 will plus 1, 4 minus 1, minus 1, minus 2, 2 minus 2, 0 minus 1, 1 minus 3, which is equal to 4, 3, minus 3, 0, minus 1, minus 2. Okay, so this is the answer to the question 4, 3, minus 3, 0. That is it. We have option B as the answer. Hope you understood that. Let's move to the next question then. Question number 21. This is section B question. Section B contains 16 questions. You have to attempt 16 questions out of the questions which are given from 21 to 40. Each question is carrying 1 mark. Let's start with the question. The function fx is defined by this function. It is increasing in which of these intervals? Okay, you are given that the function is 2x cubed minus 15x squared 36x plus 6. Let's find out the first derivative. This will be equal to 6x squared minus 30x plus 6. Now it is given that this function is increasing. If this function is increasing, then this is greater than equal to 0, or 6x squared minus 30x plus 36 is greater than equal to 0. Dividing both sides by 6, you will get 6x squared minus 5x plus 6 is greater than equal to 0, or x squared minus 3x minus 2x plus 6 is greater than equal to 0. The two factors will be x minus 3 and x minus 2 greater than equal to 0. Okay. So see, if I plot it on the graph, this is the graph. Here's the pointer 2 and 3, right? So between 2 and 3, it is going to be negative, because if both are negative, then only this is going to be greater than equal to 0. On either side of it, it is positive. Correct? So it is increasing in this portion, this one, and this one portion. Therefore, x belongs to minus infinity to closed interval, union 3 to infinity, right? And this is your C option. Option C is the correct answer. Hope you understood that. So next is question number 22. You are given x is equal to 2 cos theta minus cos 2 theta. Let's write it down. X is 2 cos theta minus cos 2 theta, and y is equal to 2 sin theta minus sin 2 theta. You have to find out dy by dx. Let's find out dx by d theta first, and here I will find out dy by d theta, and then I will divide both of them to get dy by dx. Okay. So dx by d theta is equal to, this will be minus 2 sin theta plus 2 sin 2 theta. Okay. And what will be dy by dx? This will be 2 cos theta minus 2 cos 2 theta. And you have to find out dy by dx. This is nothing but dy by d theta divided by dx upon d theta, which will be equal to 2 cos theta minus 2 cos 2 theta whole divided by minus 2 sin theta plus 2 sin 2 theta. Okay. Let's multiply the numerator and divide the numerator and the denominator by 2. All right. So this will become not 2. Here will be cos theta minus, this will be cos theta minus cos 2 theta whole divided by, this is the positive one, so I will take it here, sin 2 theta minus sin theta. So cos theta minus cos 2 theta divided by sin theta, sin 2 theta minus sin theta. This is option B. So this is the correct answer to the question. Hope you got that. Let's move to the next question then. Number 23, what is the domain of this function cos inverse 2x minus 3? You have to find out the domain of it. Cos inverse, this lies between minus 1 to 1. So minus 1 is less than equal to cos inverse 2x minus 3 is less than equal to 1, right? So this is, this angle lies. Question number 23, what is the domain of the function cos inverse 2x minus 3? So this is the given function cos inverse 2x minus 3. You know the value of this lies between minus 1 and 1. So this cos inverse, or whatever the value, like cos values always lie between minus 1 and 1. So this will give you, like I'll take 3 on this side. This will be 2 less than equal to 2x less than equal to 4. Yeah, so this will be, I'll say 1 is less than equal to x is less than equal to 2. So therefore, x belongs to 1, comma 2, or this is the domain, or the domain of function of x is given by 1, comma 2. That makes your option D to be the answer. Hope you got that. Next is 24th question. A matrix A is given by Aij. It's a 3 by 3 matrix. It's defined by these 3 functions. When I is less than j, by this function. When I is equal to j, it is given by 5. And y is greater than j, it is given by 3i minus 2j. The number of elements in A which are more than 5. So this is simple, right? You have to make the elements. First of all, the A matrix is given by, this is a 3 by 3 matrix. So this is first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, then third row, first column, and third row, second column, and here is third row, third column. So this is given by, see, when I is equal to j, this is 5. So first of all, this is 5, this is 5, and this is 5. Okay. Then when I is less than j, so when I is less than j is this, this, and this. That's it. So these are the three ones in which I is less than j. It is given by 2i plus 3j. So this will be given by 2 into 1 plus 3 into 2. Similarly, 2 into 1 plus, so I'm writing it right outside, 2 into 1 plus 3 into 3. And here is I is greater than j, this, I is greater than j, this. So these are the three values in three terms in which I is greater than j. So these are the three ones. 3i minus 2j. So 3i minus 2 into 1, 3 into 2 minus 2 into 3. And here you have a, sorry. No, wait, this one is not correct. This is, in this I is less than j, right? So I will use this one, 2i plus 3j. 2 into I plus 3 into 3. And here is 3 into 3 plus minus, sorry, 3 into 3 minus 2 into 1. And this is 3 into 3 minus 2 into 2. Okay, let's write it properly now. This is 5. This is 2 plus 6, that is 8. 2 plus 9, 11. 6 minus 2, 4. 5, 5. And 4 plus 9, this is 13. 9 minus 2, 7. And 9 minus 4, this is 5 again. So this is the matrix 5, 8, 11, 4, 5, 13, 7, 5, 5. Now the question was the number of elements in A which are more than 5. How many elements are more than 5? This is 1, 2, 3, 4. So there are 4 elements which are greater than 5. Hope you got that. So the answer to the question is option B. Let's move to the next question, number 25. It says a function f is defined by fx. It's given by this function if x is not equal to pi by 2 and it is equal to 3 if x is equal to pi by 2. This is continuous at x is equal to pi by 2. Then what is the value of k? Fine. You are given the function is continuous at pi by 2. If it is continuous at pi by 2, if function is continuous at pi by 2, limit x approaching pi by 2, fx should be equal to f of pi by 2, right? That means limit x approaching pi by 2, k into cos x whole divided by pi minus 2x is equal to 3, because you are given that x is equal to pi by 2, the value is equal to 3. Okay. So now this can be written as, I'll take the k outside, limit x approaching pi by 2. I'll convert the cos into sine. So this is sine pi by 2 minus x whole divided by, I'll write 2 over here, pi by 2 minus x. This is equal to 3, right? Now let's take the 2 outside also. You will have here k by 2, limit x approaching pi by 2 sine pi by 2 minus x divided by pi by 2 minus x. So you know what this thing, when limit x approaching a, sine of a. Question number 25. If a function f is defined by fx is equal to k cos x divided by pi minus 2x, if x is not equal to pi by 2 and it is given by 3, if x is equal to pi by 2, this is for continuous at x is equal to pi by 2, then what is the value of k? Okay, you are given the function is continuous. Function is continuous at x is equal to pi by 2, it's given, right? If it is continuous, then limit x approaching pi by 2, fx will be equal to f of pi by 2, correct? So that means here you have limit x approaching pi by 2 k into cos x pi minus 2x should be equal to 3. Let's take the k outside. Limit k into limit x approaching pi by 2. I will write here the cos x can be written as pi by 2 minus x because it lies in the first quadrant. Cos and sine both are positive over there. Divided by pi minus 2x is equal to 3. So here you have k into limit x approaching pi by 2 sine pi by 2 minus x upon, I'll take the 2 outside, here will be pi by 2 minus x is equal to 3. Now it will be, I'll take the k upon 2 outside, limit x approaching pi by 2 sine pi by 2 minus x divided by pi by 2 minus x is equal to 3. Now this whole thing, this is equal to 1, right? That makes k by 2 multiply 1 is equal to 3, which gives you k is equal to 6. So this is the value for k. Option C is the correct answer. Hope you understood that. Next is question number 26. Now, this is a matrix problem. For the matrix X is given by this. What is the value for x square minus x? Very easy question actually. You have x as 0, 1, 1, 1, 0, 1, 1, 1, 0. What will be the value of x square? This will be given by this multiplied by 0, 1, 1, 1, 0, 1, 1, 1, 0. Okay. So this is equal to first row, first column multiplication. That will be equal to 0 plus 1 plus 1, 0 plus 0 plus 1, 0 plus 1 plus 0. This will be 0 plus 0 plus 1, 1 plus 0 plus 1, 1 plus 0 plus 0, 0 plus 1 plus 0. This will be 1 plus 0 plus 0, 1 plus 1 plus 0. Okay, so this matrix will give you, this will be equal to 2, 1, 1, 1, 2, 1, 1, 1, 2. Right, that is equal to x square. Now you had to find out what in the question was required, x square minus x. So this becomes 2, 1, 1, 1, 1, 2, 1, 1, 2 minus, what was x? Let's write down x. 0, 1, 1, 1, 0, 1, 1, 1, 0. So this will be equal to 2 minus 0, 2, 0, and here was 0 again, 0, 2, 0, 0, 0, and 2. So this is a diagonal matrix. I'll take the 2 outside now. This will be 2 identity matrix 1 0 0 0 1 0 0 0 1. So this is the answer to the question. This is nothing but your identity matrix, right? So this will be 2 into I. That makes option A to be the answer for this question. Hope you got that. Let's move to the next question, number 27. Let x be given by x squared, where x belongs to the natural numbers and the function f be natural numbers to x is defined by fx is equal to x squared, where x belongs to the natural numbers. Then this function is injective, not bijective, subjective, or bijective. Which type of function is this? Okay. Suppose we have two values, x1 and x2, which belongs to the natural numbers. Okay. And f x1 is equal to fx2. Then what will happen? X1 square will be equal to x2 square, or x1 square minus x2 square will be equal to 0, or x1 plus x2 into x1 minus x2 is equal to 0, which makes simply x1 is equal to x2. Therefore, fx is injective function. Also, the elements like 2 and 3, they have no pre-imagined elements like 2 and 3 have no pre-image in N, thus fx is not surjective. All right, which means it option A has to be the answer. Hope you understood. Next is question number 28. The corner points of the feasible region of the linear programming problem are this, and this. The minimum value of the objective function z is equal to 2x plus 5y at the point is. So this is actually a very easy question. You are given that z is equal to 2x plus 5y. You are given the 4 points. This is P05. This is Q1, 5, R4, 2, and S12, 0. At this point, what will be the value of z? This is equal to 2 into 0 plus 5 into 5, which is equal to 25. At this one, z is equal to 2 into 1 plus 5 into 5, which is 27. Here, z is equal to 2 into 4 plus 5 into 2, that is equal to 18. Here, z is equal to 2 into 12 plus 5 into 0, which is 24. So, what is the minimum value? It's 18. The minimum value of z occurs at R. Minimum value of z occurs at R4, 2. That makes your option, C to be the answer. Right? Hope you got that. Next question number 29. Equation of the normal to this curve at this point is. So you have to find out equation of the normal to this given curve at this given point. Fine. The given curve is a y square is equal to x cube, right? Let's differentiate it with respect to x. You will have 2ay dy by dx is equal to 3x squared. Differentiating both sides with respect to x. So you have 2ay dy by dx is equal to 3x squared, or dy by dx is equal to 3x squared upon 2ay. Now, slope of the tangent at the point, slope, this represents slope, right? You know that. The first derivative actually represents the slope. So, slope of the tangent, this is slope of the tangent to the curve. You are given the point am square, am cube. This is dy by dx is at am square, am cube is 3 into am square into 2 into a into am cube. This will make it 3a square m raised to power 4, 2a square m raised to power 3. A square will cancel, this will cancel, and you have 3 by 2m. Right? This is the slope of the tangent at this point. You have to find out the slope of the normal at this point. Slope of normal to the tangent at this point. You know, slope product of these slopes will be equal to -1. So this will be equal to -1 divided by slope of tangent at this point, right? And that slope was equal to this. So this is equal to -1 upon 3 by 2m, which is nothing but -2 by 3m. Now this is the equation of the normal. We have, sorry, this is the slope of the normal. What we have, this is slope of the normal. What we have to find out in the question is equation of the normal. So we already have the point. We got the slope. We will use the formula. Which formula? I'll using y1 minus y2 is equal to m into x1 minus x2 formula to form the equation. So equation of normal at am square am cube is given by y minus am cube is equal to -3 upon 2m x minus am square, which makes it 3 my minus 3am raised to power 4 is equal to minus 2x plus 2am square, or 2x plus 3my minus am square, 2 plus 3m square is equal to 0. This is the answer to the question. And let's check it matches with which option. You have option B as the answer to this question. Hope you understood that. Let's move to the next question. Question number 30, face a square matrix of order A, order 3, and determinant of A is equal to minus 5. You have to find out the adjoint of A. We know that formula. We know that determinant of adjoint of A is equal to determinant of A raised to power order of the matrix minus 1. N is order of the matrix. So therefore, adjoint A determinant is equal to, that was equal to minus 5 raised to power 3 minus 1, which is equal to 25. So this is the answer to the question, option C. It was a pretty easy question if you knew this formula. Hope you got that. Next is 31st question. The simplest form for tan inverse this expression is. Let's write down that expression first. You have to find out the tangent inverse of root 1 plus x minus root 1 minus x whole divided by root 1 plus x plus root 1 minus x. That's it. Now I will do what? I will put x is equal to cos 2 theta. So you will have theta is equal to 1 by 2 cos inverse x. Okay. Fine. So you will have here tangent inverse. Okay. You will have tangent inverse root of 1 plus cos 2 theta minus root of 1 minus cos 2 theta whole divided by root of 1 plus cos 2 theta plus root 1 minus cos 2 theta. This is, sorry, tan inverse. This is equal to tan inverse 1 plus cos 2 theta. This is the formula for 2 cos square theta. 1 minus cos 2 theta is 2 sin square theta divided by 2 cos square theta minus root of 2 sin square theta. I'll cancel the root 2 from the numerator and the denominator, and also cancel the square root and the squares. I'll be left with the tangent inverse cos theta minus sin theta divided by cos theta plus sin theta. Let's divide the numerator and the denominator by cos theta. So you will have here tangent inverse 1 minus tangent theta, 1 plus tangent theta, right? Hope you got that. So till here you are clear with this. Now, this is equal to tangent inverse 1 can be written as tan pi by 4 minus tangent theta 1 plus this can be actually written as 1 into 1. So this is again tan pi by 4. You know tan pi by 4 is equal to 1. Tan 45 degrees is equal to 1 into tangent of theta. This is the formula for tan A minus B. So tangent A, which is pi by 4 minus theta, right? You know this formula, tangent of A minus B is equal to tangent A minus tangent B divided by 1 plus tan A tan B. Okay, so that's equal to pi by 4 minus theta, but we have to retrieve our x from the theta. So theta was equal to 1 by 2 cos inverse x, which gives you the answer as pi by 4 minus 1 by 2 cos inverse x. So this was a lengthy question, but worth it. And you have option C as your answer. Hope you understood. Next is 32nd question, matrix problem. If for a matrix A, you have this matrix defined by alpha minus 2 alpha, then what is the value of alpha? Okay. This is the A matrix. Let's write first alpha minus 2 alpha. Let's find the determinant of it. So determinant is given by alpha square minus minus plus minus 4. This is the determinant of the matrix. Okay, you are question number 32. If for the matrix A, which is given by alpha minus 2 alpha, determinant of A cube is equal to, see actually this cube is outside, it should be here. Determinant of A cube is equal to 125, then the value of alpha is. Here given alpha is, let's talk about the determinant of it. So determinant of A is given by alpha minus 2 alpha, which is equal to alpha square minus 2 into minus 2, which is alpha square minus 4. This is the determinant of the matrix A. You are also given that the matrix A determinant cube is equal to 125. That means the determinant of A is cube root of 125, which gives you 5. Right. So from 1 and 2, you have alpha square minus 4 is equal to 5, or alpha square is equal to 9, which gives you alpha is equal to plus minus 3, which makes option A to be the correct answer. Hope you got that. Let's move to the next question. Question number 33. If y is equal to sine of m sine inverse x, then which of the following equations is true? You have y is equal to sine m sine inverse x. Let's differentiate both the sides with respect to x. Both sides with respect to x, you have dy by dx is equal to, so sine will be converted into cos m into sine inverse x into the derivative of m sine inverse x. So dy by dx, if I write this as y dash, this is equal to cos m sine inverse x multiply m upon root of 1 minus x square, right? I'll take root one thing. Let's say this is equation 1. And yeah, let's say this is second equation. And 1 minus x square into y dash is equal to m into cos m sine inverse x. Let's say this is third equation. Okay, now again differentiating with respect to x. Differentiating both sides with respect to x. You will have the first function to derivative of second plus second function into derivative of first. This will be equal to minus 2x upon 2 root 1 minus x square. This is equal to minus m square sine of m into sine inverse x whole divided by this again, because sine inverse x will be, the derivative of sine inverse x is going to be 1 minus x square under the root. Fine. So you can write it as y double dash is equal to, let's do the cross multiplication. You will have 1 minus x square minus x y dash, because these two things will cancel and 2 and 2 will cancel, is equal to minus m square. See, this was equal to y, right? Remember this thing. This was equal to your y. So this can be written as minus m square into y from 1. Okay. Or y double dash into 1 minus x square minus xy dash plus m square y is equal to 0, or you can write it as x minus y square into the second derivative of y with respect to x minus x into dy by dx plus m square y is equal to 0. So this is the answer to the question. Let's check. You have option B as your answer. Hope you understood that. Next is 34th question. The principal value of tangent inverse minus cot inverse minus root 3 is. Okay, so you have a tangent inverse root 3 minus cotangent inverse minus root 3. What is the tangent inverse of root 3? This is given by pi by 3 minus. So cotangent inverse minus is this. See, minus root 3 will be given at pi minus pi by 6 because I have a minus pi by 3 over here. Okay. Uh, let's discuss it over here. You have tangent inverse root of 3 is equal to, this is nothing but pi by 3, or wait, this can be written as tangent inverse tangent of pi by 3. And for the second one, that is the cotangent inverse this is equal to minus pi plus cot inverse, I'm taking this outside, pi by 6. Question number 34, you have to find the principal value of tan inverse root 3 minus cot inverse minus root 3. So tan inverse root 3 minus cotangent inverse minus root 3. Let's discuss the value. So first of all, tangent inverse of root 3 can be written as tangent inverse of tangent pi by 3, which is nothing but pi by 3. Also, cotangent inverse minus root 3, this is equal to cotangent inverse of cot of pi minus pi by 6, because it is lying in the second quadrant. See, minus 3 cotangent is negative in the second quadrant over here. Okay, so this gives you the value of pi minus pi by 6, that is equal to 5 pi by 6. Now let's fill both of these values 1 and 2 in this equation. So you will get here required equation becomes pi by 3 minus 5 pi by 6, which gives you 2 pi minus 5 pi, that is minus 3 pi upon 6, or minus pi by 2, right? So you have option B as your answer. Hope you got that. Let's move to the next question, number 35. The maximum value of 1 by x raised to power x is, let's say y is equal to 1 by x raised to power x. Taking log on both sides, you will have log y is equal to log of 1 by x raised to power x, or this is equal to log of this, or you can write it as log of x raised to power minus 1, which will become minus x log x, that was equal to your log y. Now differentiating both sides with respect to x, you will have here 1 by y dy by dx is equal to, minus will be taken, first function into derivative of second plus second function into derivative of first. So this will be equal to minus 1 plus log x. Correct? This was equal to 1 by y dy by dx. Let's say this is equation 1. Now again differentiating it with respect to x. Differentiating with respect to x. Again, you will have first function into derivative of second. First function into derivative of second plus second function into derivative of first. Is equal to, this will be 0 plus this will be minus 1 by x. Correct? Right? One thing, second function into here will be dy by dx again. Okay. So this now can be written as 1 by y upon second derivative of 5 with respect to x minus 1 by y square into dy by dx square is equal to minus 1 by x, right? Let's say this is equation 2. Okay. So from both of these, from equation 1, what did we get was 1 by y dy by dx is equal to minus 1 plus log x, or you can write down dy by dx is equal to minus y 1 plus log x. Let's say this is the third equation, right? And this is equal to, this was 1 by x raised to power x 1 plus log x. Now, for the maximum or the minimum values, you have to consider the maximum value. For the maximum and the minimum values, the first derivative should be equal to 0. For max or minimum values, dy by dx should be equal to should be put equal to 0. That means 1 minus 1 upon x whole raised to power x into log 1 plus x should be equal to 0. However, 1 by x raised to power x, this cannot be equal to 0 for any value of x, right? This cannot surely be equal to 0 because x cannot be 0, and for any other value, this cannot evaluate to be x. That means 1 plus log of x, this is surely equal to 0, or log of x is equal to minus 1, which gives you x is equal to e raised to power minus 1, or that is equal to 1 by e. Fine. Now, you have to find the maximum or the minimum value, right? When you put x is equal to 1 by e, from the from the third equation, no, I'll take the second one only, this equation. Okay, from the second equation, let's write down, let's see the equation once. Fine. So from the second equation, you will have here 1 by y d squared by dy minus 0 is equal to minus e, or d square y upon dx square is equal to minus e into e raised to power 1 by e is less than 0, because this is, we are considering the maximum value. So this has to be less than 0. Hence, y is maximum when x is equal to 1 by e, and maximum value of y is equal to e raised to power 1 by e, right? So let's check with the options, which option you have in the answer. That is your option A. Hope you understood that. Let's move to the next question then. Question number 36. Let the matrix X be given by Xij. It's given by this. Then the matrix Y Mij, where Mij is the minor of Xij. Okay, to understand this, first of all, what is the Mij? See, Mij will be M11, 12, 13, 21, 22, 23, 31, 32, and 33. Okay, so let's find out the M11. M11 will be given by 4 minus 5 minus 1, 3. 4 minus 5 minus 1, 3. Determinant actually. Okay, so wait. And M12 is similarly first row, second column I am leaving. So 3 minus 5, 2 and 3. M 1, 3, 3, 4, 2 minus 1, 2, 1. This is minus 1, 2, minus 1, 3, 2, 2, 2, 3. M 2, 3. This is 1 minus 1, 2 minus 1. And M3, 1. This is minus 1, 2, 4 minus 5. M3, 2 is 1, 2, 3 minus 5, 3, 3, 1, -1, 3, and 4. Let's find out the determinants now for all of them. Okay. So this is equal to 12 minus 5, which is 7. This is 9 plus 10, 19. 3 minus 3 minus 8. This is equal to -11. Minus 3 plus 2 minus 1. 3 minus 4 minus 1. -1 plus 2. 1. 5 minus 8 minus 3 minus 5 minus 6. This is -11. 4 plus 3, which is equal to 7. So what does the Y matrix become now? Y is equal to 7, 19, -11, -1, -1, 1, -3, 11, and 7. So this is the answer to the question. Let's check with the options. You have option D as your answer. Hope you got that. Next question number 37. A function f defined by real numbers to real numbers is defined by fx is equal to 2 plus x squared. This is which type of function? Not 1, 1, 1, 1, not onto, neither 1, 1, not onto. You're given the function fx is equal to 2 plus x squared. For 1, 1 function, 1 to 1 function, you have f of x1 is equal to f of x2, or 2 plus x1 square should be equal to 2 plus x2 square, or x1 square should be equal to x2 square, which makes x1 should be equal to plus minus x2, right? So either x1 is equal to x2 or x1 is equal to minus x2, right? This is not the thing. Therefore, see, either x is equal to x2, or both the things they simultaneously can't be equal, right? Therefore, the function is not 1, 1, right? Let's check for onto now. So for onto, let's say fx is equal to y. Let's say fx is equal to y such that x square is equal to y minus 2, or x is equal to plus minus root of y minus 2. If I put y is equal to -3, we'll get x as plus minus root of -5, which is not possible as the root of a negative number is not a real number, which is not possible as root of negative numbers is not real. Therefore, x is not a real number. Hence, fx is not onto function as well, right? We check for both of them. That means it's neither 1 to 1 nor onto, and option D is the correct answer. Hope you understood that. Next question number 38. A linear programming problem is as follows. Maximize, minimize objective function given by z is equal to 2x minus y plus 5 subject to these three constraints. If the corner points of the feasible region are this, which of the following is true? Maximum value of z is this, minimum value of z is this. Difference between maximum and minimum value of z is 35. At two corner points, value of z are equal. Which of these four options is correct? Fine, you are given that z is given by this, and you are given four corner points. We are not bothered about the constraints right now because we are given the points as such. So let's find out. Z is equal to 2x minus 5 plus 5. At the point 0, 10, you have z is equal to 2 into 0 minus 10 plus 5. This is equal to minus 5. For the point B, 12, 6, you have z is equal to 2 into 12 minus 6 plus 5, which is 23. At the point C, 20, 0, you have z as 2 into 20 minus 0 plus 5, which is equal to 45. And the point D, not D, you have O. 0, comma 0. So this is 2 into 0 minus 0 plus 5, which is equal to 5. Right. Now, the first option, the maximum value of z is 40. That is wrong. The minimum value of z is minus 5. This is correct. Absolutely correct. So I think we got our option. Let's still check the C option, maximum and minimum value of z differences. So this is the minimum value and this is the maximum value. The difference between them is 50. So even this is wrong and no two z values are equal. So we have only option B as the answer. Hope you got that. Next is 39 question. If x is equal to minus 4 is a root of this matrix, determinant is equal to 0, then sum of other two roots is equal to. Okay, let's find out the determinant of this matrix first. This is x into x squared minus 2 into x minus 3 plus 3 into 2 minus 3x. This is equal to x cube minus 2x plus 6 plus 6 minus 9x. So this is x cube minus 13x plus 12 is equal to 0. Right? Since we have, you are given x is equal to minus 4 is a root. That means x plus 4 is equal to 0 is a factor. Right? X plus 4 is a factor. Since x plus 4 is a factor of this equation, also sum of roots is given by minus b upon a, where b is the coefficient of x square and a is the coefficient of x cube. X square coefficient is missing. So this is 0 upon 1, which is equal to 0. So the sum of roots of this equation is equal to 4. Let those three roots, this equation is going to have three roots, a plus b plus c is equal to 0. And one root is given to you as x is equal to minus 4, right? So let that root be c. So let c is equal to minus 4. Out of these three roots, one root is equal to minus 4, which means a plus b minus 4 is equal to c, or a plus b is equal to a plus b minus 4 is equal to 0, or a plus b is equal to 4. Therefore, the sum of other two roots is equal to 4. That makes your option A to be the correct answer. Hope you got that. Let's move to the next question. Question number 40, the absolute maximum value of the function fx is equal to 4x minus 1 by 2x squared in this interval is. Let's find out the first derivative of this function. This is 4 minus 1 by 2 into 2x, which gives you 4 minus x. So for the maximum or the minimum value, this is equal to 0. That means 4 minus x is equal to 0 or x is equal to 4. Then we evaluate the f at the critical points. We evaluate f at critical points, x is equal to 4, and at the end points of this given interval, at the end points of the interval, which is minus 2 to 9 by 2, which makes f of 4 is equal to 16 minus 1 by 2 of 16, that is equal to 8. And f of minus 2 is equal to minus 8 minus 1 by 2 of 4, which is equal to minus this minus this, that is equal to minus 10. Also, f of 9 by 2 is equal to 4 into 9 by 2 minus 1 by 2 into 9 by 2 square, which is 18 minus 81 upon 8, that is equal to 7.875. Thus, the absolute maximum value, thus the absolute maximum value of f on minus 2, 9 by 2 is 8, which is occurring at x is equal to 4. At x is equal to 4. Okay, so that makes your option A to be the correct answer. Hope you got that. Let's move to the next question. Question number 41. In this, you are starting with the section C. You have to attempt any 8 questions out of 41 to 50. Each question is of 1 mark. In a sphere of radius R, a right circular cone of height h having maximum curved surface area is inscribed. The expression for the square of the curved surface area of the cone is. Let's make the figure to understand the problem first. So here is the circle because the cone is said to be inscribed. So this is the circle. Let's make a cone now over here. This is the cone. And this is the like this. And we have like this over here. Okay. Now, let's say this also. Fine. This is the center. Let's say this is the radius. And the slanting length L, slanting length L. Let's say this is the point R. This is capital R. This is A, B, C. Okay, these are the points. Fine. So radius is given to be R, the right circular cone of height h. So that means this total height BC is equal to h. If BC is equal to h, then if this is O, the center of the circle, then OC is equal to h minus R. Okay. Hope you are clear with this, right? Having the maximum curved surface area is inscribed the expression of the square of the curved surface area of the cone. So here the curved surface area of cone is given by the formula pi r L, where r is this radius of the cone. Okay. And let's write down over here, radius of the sphere is equal to small r, and radius of cone is equal to capital R. Height of cone is taken as h. So now in the triangle AOC, if I consider this triangle, this is of course the radius of the circle, sphere. In triangle AOC, OA square is equal to AC square plus OC square, or R square is equal to capital R square plus H minus R square, which gives you R square is equal to R square minus H minus R square, which is equal to R square minus H square minus R square plus 2HR, or you have here 2HR minus H square, that is equal to capital R square. Therefore, radius of cone R is equal to root of 2HR minus H square. I hope you're clear with this till here. This is, let's say, equation 1. Now, I'm considering the triangle ABC. In the triangle ABC, AB square is equal to AC square plus BC square. That means L square is equal to capital R square plus H square. Or L square is equal to 2HR minus H square plus H square, which is equal to 2HR. That is, L is equal to root of 2HR. Let's say this is your equation 2. And this is your slant height. Okay. Now let's go to the curved surface area of cone, which is given by pi r L, right? So this is equal to pi into R was equal to 2HR minus H square. L was equal to 2HR. So this is equal to, let's do the squaring of the both sides. Curved surface area of cone square curved surface area of the cone square is equal to pi square into 2HR into 2HR minus H square. Correct? Or this is equal to 2 pi square R into 2RH square minus H cube. Now let's check it matches with which of the given options. Option C is the correct answer. Hope you got that. Let's move to the next question, number 42. The corner points of the feasible region determined by the set of constraints linear inequalities are P, Q, R, S. And the objective function is this, where a and b are greater than 0. The condition on a and b such that maximum z occurs at q and s is given by. So in this question, you have to maximize z, right? Which is ax plus 2by. Now, maximum value, it's given that these are the 4 corner points, right? The corner points of the feasible region determined by these constraints are this objective function where a and b greater than 0. The condition on a and b such that maximum z occurs at q and s. So we are given the 2 points in which it occurs maximum. The q point was given to you as 3, 5. So for 3, 5, the value of z comes out to be 3a plus 10y. And also it is occurring at S. So S is given by the point 4, 1. For this point, Z is equal to 4A plus 2Y. Okay. So I have 2 equations. What you need to find out is the value of A and B. So let's solve them simultaneously. I'll multiply this with 5. So you have 3A plus 10Y. 20A plus 10Y is equal, fine. Okay, these are both the maximum values, right? So 3A question number 42, the corner points of the feasible region determined by a set of constraints, linear inequalities are P, Q, R, and S. Objective function is given by Z is equal to AX plus 2BY. When A and B are positive, then the condition on A and B such that the maximum Z value occurs at Q and S is. First of all, Z is given by AX plus 2BY. Maximum value occurs at X and S. So maximum value of Z at Q is equal to value of Z at S. Okay, because they are the maximum values, correct? So what is the Q point? Q is 3 by 3, 5. For that, Z becomes 3A plus 10Y. And for S, the point is 4, 1. For this, the Z is equal to 4A plus 2Y. So according to the question, they are both the maximum values. That means they are equal to each other. Or you can say 3A plus 10Y is equal to 4A plus 2Y. That makes minus A plus 8y is equal to 0, or 8 minus, wait, not y, here was supposed to be b. Oh, because we filled the value for y, right? So this was supposed to be b everywhere instead of y. So that makes 8 minus 8b is equal to 0, which is your option C. Hope you got that, right? Next is question number 43. If the curves y is square is equal to 4x and xy is equal to c cut at right angles, then what is the value of c? They're given the two curves y square is equal to 4x and xy is equal to c. They are at right angles, so they are orthogonal to each other. Let's say they intersect. Let's say they intersect at x1, y1. Okay. So if I take this equation, let's differentiate both the sides with respect to x. You have 2y, dy by dx is equal to 4, or dy by dx is equal to 2 upon y. Also, you have x, y is equal to c. Let's differentiate. First function to derivative of second plus second function into derivative of first. This is equal to 0, or dy by dx is equal to minus y upon x. Now dy by dx at the point of intersection, which was taken to as x1, y1, is equal to 2 upon y1, and over here dy by dx at x1 y1 is equal to minus y1 upon x1. Okay. So let's say these are the two equations, 1 and 2. So from 1 and 2, both are equal, right? From 1 and 2, 2 upon y1 is equal to minus y1 upon x1. Sorry, they are orthogonal to each other. So this product of their slopes is equal to 0. Product of their slopes is equal to minus 1, not 0, sorry, it's minus 1, because they are perpendicular to each other. They are orthogonal or perpendicular to each other. Okay, so that means 2 into y1, 2 upon y1 multiplied by minus y1 upon x1 is equal to minus 1, which gives you minus 2 upon x1 is equal to minus 1, or x1 is equal to 2. If xn is equal to 2, I'll use the equation y squared is equal to 4x. For x is equal to 2, what will be the value of y? It will be 8. Y squared will be 8, or y will be equal to 2 under the root 2. Okay. Now let's put the value of x1 and y1 in the other equation as well. See, you had this xy is equal to c. You have to find out the value of c. So x1 came out to be 2. Y came out to be 2 root 2. You had xy is equal to c. It was given in the question. So 2 into 2 root 2 is equal to c, which makes it 4 root 2. That's it. This is the answer to the question. 4 root 2. Option A is the correct answer. Hope you got that. Next question number 44. The inverse of the matrix X, which is given by this, is so simple as that. Let's find out the inverse of this matrix. Question number 44. The inverse of the matrix X, which is given by this, is. See, this is a diagonal matrix because all the elements except the diagonal elements are 0. And the inverse of diagonal matrix is very simple to find. It is the inverse of the diagonal matrix is obtained by replacing each element by its reciprocal. Each non-zero element by its reciprocal. By replacing each non-zero element by its reciprocal. So this will be given by 1 by 2, 0, 0, 0, 0, 1 by 3, 0, 0, 1 by 4. And this matches with option D. So this is the correct answer to the question, option D. Hope you got that. Next, let's move to the question number 45, sorry. So now for a linear programming problem, LPP, the objective function is given by z is equal to 4x plus 3y, and the feasible region determined by the set of constraints is shown in this graph. Which one of the following statements is true? Number 1, maximum value of z is at R, which is this point. Maximum value of z is at Q. Maximum value of, value of z at R is less than the value of P. The value of z at Q is less than the value of R. Okay. So in any case, we need to find out the value of z for either of the points. So the first point is this origin 0, 0. Z is given by 4x plus 3y, and for origin, the coordinates 0, 0. Z is equal to 4 into 0 plus 3 into 0, which is equal to 0. And now the point P here is 0, 40. So this is Z is equal to 4 into 0 plus 3 into 40, which is equal to 120. For the point Q, which is this point, right? Wait. Yeah. Okay, for the point Q, which is this point, which is 30, 20, the value of Z comes out to be 4 into 30, plus 3 into 20, which is equal to 120 plus 60, or this is equal to 180. And the last R, which is given by 40, comma 0. The Z is given by 4 into 40 plus 3 into 0, which is 160. Therefore, see, this is the maximum value, and the maximum value is at Q. So we definitely have option B as the correct answer. So option B is the correct answer to the question. Hope you understood that. Let's move to the next question. Question number 46. This is a case study. It says in a residential society which is comprising of 100 houses, there were 60 children between the age of 10 to 15 years. They were inspired by the teachers to start composting to ensure the biodegradable waste is recycled. For this purpose, instead of each child doing it only for his her house, children convinced the Residents Welfare Association to do it as a society initiative. For this, they identified a square area in the local park. Local authorities charged a rupees 50 amount per square meter for space so that there is no misuse of space. And Resident Welfare Association takes it seriously. Association hired a laborer for digging out 250-meter cube, and he charged rupees 400x depth square. Association will like to have the minimum cost. So the question is, let the side of the square plot is x meters and its depth is h meters. Then the cost C for the pit will be which of these options? Fine. See, square plot, the side is given to as x meters and the depth is h meters. You have to find the cost C. So cost will be given by, see over here, it is asking for association hired a labor for digging out 250 meters. So this will be 250 meter cube of the volume multiplied by, this is rupees 50 per square meter. Now, this is divided by the height h in meters plus 400 rupees multiplied by h square. Question number 46. This is a case study. It says in a residential society which is comprising of 100 houses and 60 children between the ages of 10 to 15 years, they were inspired by the teachers to start composting to ensure the biodegradable waste is recycled. For this purpose, instead of each child doing it only for his her house, children convinced the Residents Welfare Association to do it as a society initiative. For this, they identified a square area in the local park. Local authorities charge rupees 50 per square meter so that there is no misuse of the space, and Resident Welfare Association takes it seriously. Association had a laborer for digging out the 250-meter cube, like a hole, and he charged rupees 400 times the depth square. Association will do like to have the minimum cost. For that reason, for this whole problem, now the question is, let the side of the square plot be x meters and the depth h meters. What will be the cost C for the pit? Okay, so see, the cost C for the pit will be the labor was hired for digging out 250-meter cube of the pit multiplied by 50, because here is this 50 multiplied by 50 divided by this depth, which is given by h plus 4. This is again the cost which is taken by the laborer, 400 times the depth square. Okay, so that's it. See, 50 rupees is charged for the square plot, for the plot square meter per square meter, and this was a total volume which was needed to be dug out. So 250 divided by h multiplied by this 50 plus 400 into h square is the cost which will come. So this makes this is equal to 12500 upon h plus 400 h square, which makes your option B to be the answer to this question. Hope you understood that. Next question. So the same case study is there. Now it's saying the value of h in meters for which dc upon dh is equal to 0. Let's get back to our equation. We had the C as 12500 upon h plus 400 into h square. Let's differentiate it with respect to h. You will have minus 12500 upon h square plus 800 into h. Now this is let's put this is equal to 0. You're given dc upon dh is equal to 0, which makes minus 12500 upon h square plus 800 into h is equal to 0, or you will have 800 h cube minus 12500 is equal to 0. 800 h cube is equal to 12500, 0 will cancel. You have h cube is equal to 125 upon 8, or h will be equal to cube root of this, which is 5 upon 2. That is equal to 2.5 meters. This is the answer to the question, 2.5 meters. We have option C as the answer. Hope you got that. Next question number 48. The same case study is there. Now, it is asking you d squared, the second derivative of c with respect to h. What is that? So, d squared c upon dh square. This is the derivative of d c upon dh, which is equal to d upon dh of minus 12500 upon h plus 400 h. No, sorry, this was plus 800h, right? From the previous question, you can check that. Okay. So the second derivative now will be equal to, here was h square. You can refer to the previous question for this value. So the second derivative now, this is equal to minus of minus 2 into 12500 upon h raised to power 3 plus 800. That makes it 25,000 upon h cube plus 800 is equal to d square c. That is the second derivative of c with respect to h. Okay. And you have option A as your correct answer. Hope you got that. Next question number 49. Now the same case study, and the question is the value of x in meters for minimum cost. See, when the cost for the minimum or the maximum cost, the first derivative of the cost with respect to h will be equal to 0 for minimum cost. Okay. So here, see, what we found out in the last question was h is equal to 2.5 meters, right? At h is equal to 2.5 meter, what was this value? It was equal to 25,000 upon h cube plus 800. So at h is equal to 2.5, this is definitely a positive value, right? At h is equal to 2.5, right? So hence, we have minimum cost at h is equal to 2.5 meters. Now, what is the value? Actually, in the question, we are asked for the value of x for which the cost is minimum. So, x is given by root of, over here, x is given by 250 meter cube upon h. How did I come to this formula? Let's discuss. You were given that the side is equal to x and depth is equal to h. Volume will be equal to, since this was the square, remember? So the volume will be given by x into h. Volume is equal to 250. We are given this. So this is x square into h. So we have to find out x will be given by this. Hope you got that, right? Now let's get back. We will have already had the value of h as 2.5. This makes this as 250 into 10 upon 25, which is equal to 10 meters, right? So the value of x for the minimum cost is 10 meters, which is option B. Hope you understood that. Next is the last question for this paper. That is the question number 50. it says the total minimum cost of digging the pit in rupees is. Okay, now see, it is asking for the minimum cost. We already talked about the cost will be minimum when the height is 2.5, right? So we already derived the formula for the cost. It was equal to 12500 upon h plus 400 into h square. So this is 12500 upon 2.5 plus 400 into 2.5 square, which is equal to, this will be equal to 5000 and this will be equal to 2500, which gives you a total of 7500 rupees. So this is the answer to the question, and we have option B as the correct answer. Hope you understood that. So students, with that, we have completed all the 50 questions of this paper. Hope, hope they were clear to you and you understood them well. Students, don't forget to visit our website, www.examsnet.com. This site is a great tool for you to practice your entrance exam question papers as well as class 12 mathematics, physics, chemistry question papers also. You must download our app. The link is available in the description box. That's all for this paper. Keep shining, keep rising high. Bye.